Let's let's start with this because last time we have a Zoom class, so not sure how much you're learning. So maybe we start with a question so that you can tell me that what you have learned in the last class. So I can see how well you've been doing. So try to fill that in. We'll start in 2 minutes, maybe a little bit longer, right? Maybe make 3 minutes. So for those who arrive late, we start with a question today because on Wednesday we have a Typhoon Zoom class. So try to see what you have learned by asking how well you're doing. Um, because I guess it has been not that easy. So let's see how much you remember. Um, I forgot. So the first one is we study the probability mass function and cumulative function. Yes, exactly, because we learn um, the probability mass function is big P and the cumulative function is the big F, and they are the different way to describe a random variable. Okay, just to remind you that we have learned the random variable is the way to give number to outcomes of a random experiment, and then the probability mass is just tell us that for this particular number, what is the probability, and cumulative distribution is asking what's the probability that the random variable is equal to or less than that number. Okay, and then we know how to jump between the P, big P, and big F, right? If you stack the P, it become F. If you unstack the F, they get the P. Okay? And last class, we also learned the expectation okay, which is the mean of the outcomes of random variable. Okay, right? Imagine that you have a random experiment, you have that outcome many times, and each outcome can be associated with a number using random variable, right? And your bunch of numbers, and average of those number will be our expectation. Okay. And we learn some discrete and continuous. Okay. Learn some equations. Okay. And also we learn not just expectation, we also learn variance, right? And in particular, variance is to be related to our topic one, right? Is that it measures how good our mean is, okay, and it related to the finance application of a measure of risk, right? And that is we have. Okay, so seems like you're okay. Now we are going to the slide. Okay, so let's quickly review and then we go forward. Okay, because I know learning in the Zoom is not that easy. Because it's very tempting to do other things. So that's why you all come to the school and study rather than staying at home and watching, right? And also, right, there's a study actually talking about whether you have an iPad on your table or a laptop on the table affect your study. I think there's a study in the West Point or some military academy in the US, and they figure out that if you simply put the iPad on your table, are already a distraction. Of course, the on is another distraction. Same for the other thing. But of course, you may not believe that there's a random there's a experiment on that. But so, but at least I'm here, so you are at least less distracted from that. So just to remind you what we've done, I have said random variable is assigning numbers to outcome. Okay. And we have different type, discrete, continuous. And I think we have example, head or tail already. So I'm not going to repeat that. Instead, I want to maybe draw a picture to summarize what we have done. Okay. So let's draw the sample space S. Okay. Is head or tail. Right. Maybe even easier. Well, outcome more abstract, ABC. Okay. And we can say we can map to some number. Okay. 1 and 2. Okay. And A I map to 1. And B and C are mapped to 2. Okay. And this is the random variable X. Okay. X is the random variable. And this is a discrete case because I map everything to integers or a finite number of numbers. Okay. And I would say, right, we have from the X sum probability, right? This is some PA. Okay. This is some PB and this is some PC, right? And of course, axiom would say this would happen, right? And from science or engineering or from data, we know PA, PB, and BC, or we guess what it is, right? So they have to be up to 1, right? And they must be 0 to 1, right? Now, what we learned from the last class is, right, there's a way to describe this is what we call through the P of 1 and P of 2, right? And P of 1 is I give you a number, you give me the probability. In this particular case, P of 1 will be just simply PA, right? And P of 2 will be probability B plus probability C, right? So this is what the P function does, right? It's telling us that, okay, look at the outcomes, okay, how it goes to the numbers. But each outcome will have some probability. You just add them up, right? Give me the big P there, right? So this is how the P is being used, right? And of course, you can also do the same for the F, right? In this particular case, let me use the color purple, right? F of 1 is simply P of 1 is PA, right? And F of 2 will be P1 plus P2, right? Because F of 2 is asking that what's probability the random variable X is less than or equal to 2, right? So it's just 2 cases. Then simply PB, PA, maybe ABC, right? It's better to write that way. One, right? So that would be and then you can see if you subtract F2 to F1, give you P2, right? You subtract F1 to 0, give you P1, right? So you can always go between F and P, so that should be no problem from you to go one from the other. Okay, there's the same way to represent, right? So this is what we learned last time. And we also learned another thing is we call the expectation and the variance, right? And the expectation will be you multiply each number in the random variable by its probability and add together, right? So in this case will be 1 times PA, right? 1 times PA plus 2 times PB plus PC, right? So that would be the variance. So the expectation, right? And the variance will be simply the same thing, but be 1 minus, let's call this, I don't know, let's call this mu, okay, a notation. 1 minus mu square PA, right? And then 2 minus mu square PB plus TC, right? So do note that PA, PB, BC will be some number, say maybe 0.1, 0.3, 0.6, something like that, right? Or so that will be we just learn to summarize what we learned last time, okay? But of course, nothing new there. It's everything in your notes. Because I just save time in revising instead of going through every single slide, I just do it in this way because I think this is how you learn, right? You have to grow from different perspective, not the same one. So look at different direction. If you understand a different way I present the same thing, then probably you understand. If you don't understand, then probably you have to read that again. Okay. Is that okay? I hope this is nothing new from what we have done. Okay. So you can see how the connection between this topic to the previous one, right? Its only thing is that I put number to outcome. Okay. In that case, instead of giving probability to each outcome, I have a function which tell me you give me the number, I give you the probability. Okay. And same goes for the F. Okay. Is there no question there? Do we need to take a look longer? Is it okay? Is there any question? This is what we cover. I mean, there are 2 more formula we want to say, but this is the major thing we cover. Okay. Is there any question? Because I suspect when you learn it from the computer, it's not that easy to remember, right? So that's why when you go to a concert, right, you have more fun, right? Rather than you watch YouTube, right? You see the live performance. So I think live class is better than the class that you would be doing at home watching the thing. Okay. So I hope that is clear what we have been doing. So we have done this P, and then you know how to do the P, and then F, and then we learned that you stack the P and it gives you F, and unstack the F, it gives you P. So already you have that. Now, so again, the expectation, I have to repeat the meaning, otherwise you don't know what we're doing, right? Again, why we get this formula expectation is, let's go back to the electric write board here, is why this formula makes sense. Because if you repeat this potentially, you repeat this experiment, okay, and you would be seeing that relative frequency of ABC would appear in PA, PB, BC, right? So suppose, maybe make it more concrete, right? Suppose PA is 0.2, PB is 0.3, right? PC is 0.5, right? So if you run this 10 million times, you expect to get 2 million times of A, 3 million times of B, and 5 million times of C out of 10 millions. And in that case, if that means that if you look at your data, you have 2 millions of 1 and 8 millions of 2, right? So then the average of that will be 2 millions of 1 times 1 and 8 millions times 2 and over 10 million. That's the mean, right? Right? Just add up. Then exactly is that formula, right? Because 2 million over 10 million is 0.2. 8 millions over 10 million is 0.8. So exactly the meaning, how you calculate the mu. Okay. So I hope you understand why you calculate expectation, because they are not disconnected concept. They are closely related. It's like you keep running the experiment, you generate data, right? And based on the observation, and you want to calculate the mean, right? And why this would make sense, right? Look at this example again. Hopefully, I can convince you this is good. So this example is very simple enough to repeat again, right? So we have a 2 outcome, either 0 or 1, right? And if you repeat this many times, say 1 million times, then you have a 500,000 0, 500,000, right? And you also have a 500,000 1. Okay. And this is data you have, right? 500,000 0, 500,000 1. Then you calculate mean of this data. Remind you that what's the mean? Mean is the point where you go to left-hand side, all the distance, and you go to right-hand side, all the distance. It's the same, right? So that is the meaning of distance, right? So, and exactly 0.5 is where it is located. Left and right the same. Okay? So, remind yourself in the very first class I emphasize what is mean. Mean is distance in the by middle, right? So, remember our last class we mentioned one random variable that fit our idea is if we have random variable representing the typhoon signal, right? That is, we have 0, 1, 3, 8, 9, 10, right? 0 means there's no typhoon, right? And of course, you can assign some probability, right? Depends on which day you are, right? But is expectation in this context make sense or not? The answer is no. Why? Because these typhoon numbers are just ordinal data, not numerical data, right? So if you calculate expected value of this random variable of the typhoon signal is 5.8, it doesn't mean a lot. Remember why? Because it simply means that, okay, look at this is you have a bunch of data, maybe a bunch of 0, right? Because 0 is very likely. and sum of the 1, sum of the 3, sum of the 8, and sum of 9 or 10, right? Maybe you're doing more for 8, slightly more for 9, right? And then a lot of 10 for 3, and then right? There's a lot of data point here, right? So what's the mean? It's just like the distance in the middle, I don't know, somewhere here, and then calculate distance, right? And the distance to left and right is the same, okay? But the distance mean very little in this ordinal data, right? Because is it when you jump from 3 to 8, right? Is it there's 5, right? But when you jump 0 to 1, there's only 1, right? So I'm not sure that the distance would be meaningful, right? It's just like larger than bigger, right? If you look at the history of typhoon signal, there is actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I think 5, 6, 7, 8 in old days means different direction. If you try to look at the observatory history. So the number is actually not much meaning there. Except that it's larger, the more important, right? Because 9 and 10, right, is way much different from 0 to 1, right? The difference is 1. Okay. But it's not that meaningful. So when you calculate, what I want to say is when you do expectation or do the variance, it has to be numerical data. It's ordinal, simply mean very little. Okay. They have something to say, but they still mean the distance, left and right equal, but I don't know how much importance to attach to it. Okay. So make sure that you understand this because this I emphasize in the very beginning of our class. Okay. Know your data. Okay. Don't just apply whatever you want to apply. Okay. Because it works, it calculates something. Okay. And same for the this day, more important is also with AI, right? It's easy to get data or easy to get result from AI. If you don't know what you're doing, you're bound to have trouble. Okay. Now, same for the rolling a die, you have a 6 outcome. You calculate mean would make sense, okay? But how to interpret this 3.5, right? Will you roll a die, you get 3.5? No. It just simply means that you run this roll many times. You record the outcome, and the average of this outcome is 3.5. Okay. It doesn't mean that the next outcome is 3.5 because there's no 3.5 in the die, right? So that have to be understand what's the meaning of the expectation. And I think we covered this, right? And interpretation would be X is the value of your it's the price of a shares of a stock, right? And if you invest 10 shares and you hold cash, okay, what is the value of this portfolio? Will be the number of shares you have, multiply the price of each share in expectation, plus the cash in your hand, right? So that means that you don't need to do it again, but you just need to focus on a single unit. Okay, that would be the way to look at it. I think this example, we worth going it again. You have price of the stock is 1, 2, 3, and then want to calculate the value portfolio with 100 shares and X and 300 cash, and we calculate the expected value of a share is 2. Then just very nearly is 100 times 2 and plus 300. Okay, I think we covered that. Right, I think this we covered already. And this is the formula, right? That is the expected square this difference from the mean, right? So I already showed you the formula, okay? It's no different from the formula we learned from the first class, right? The first class formula is this guy, right? If you still remember, variance of X is summation X minus X bar over N, right? And in this case, we don't need to divide N minus 1. The reason is being that we can run the experiment in our head as many as we want. So that is the population thing, right? It's not the sample. And we can't. And you can see there's no difference because this guy is correspond to this guy, right? Because how many times you repeat, okay? So that is the same thing. You just replace 1 over n by px is the formula. And we know that how to calculate the variance is already in the question there, okay? And also we cover this part, right? The variance is no longer linear, but quadratic, right? So that means that if you increase 10 shares of a stock, the variance measure will be not 10 times, but 100 times, okay? But if you look at the standard deviation, SD, okay? In particular, look at this case, SD, standard deviation, right? Standard deviation X is taking square root of variance, okay? Just to remind you this. And ask yourself, what is SD AX here? Okay. Using the math you learned in the high school, you know it's going to be this, right? Because A squared, take a square root, become A. So why, does it tell us? The risk, if you measure by standard deviation, will be linear to the size of the portfolio, okay? But if you measure by variance, will be quadratic to your size of portfolio. So, of course, the question boils down to what's the right measure, standard deviation or variance, okay? Of course, it depends on how you measure it, okay? But it's up to you to think which one is the better. But I'm just telling you that this is the way we do, okay? I think variance is a better measure, but you may think otherwise. And B is, remember, this is cash. Cash in your portfolio has no variance, right? The cash you put in the matrix, you put in the bank, usually it's not going to be gone, right? So that means that the risk of your cash has no change. The variance remain the same, right? Variance of your portfolio with stock and cash is just the risk associated with your stock only. Okay, so I hope this would make sense to you. And we already calculate this very simply, right? Here we have the stock, same distribution, we know it's 2. The variance is just you pick the value 1 here, you subtract the mean is here, right? You see, right? And then you take the probability here, right? So this is how you have the first entry, and you do the same entry for the rest, add up together, give you the value 1/2, okay? And then you can calculate the variance portfolio. If you have 100 shares of stock X and 300 cash, you can forget about cash. And if you have 100 shares, your variance is 100 squared, and you calculate, it gives you 5,000 variance. Okay? So I hope this would be fine. Now, I think we want to talk about this, okay? Is bivariate random variable, which we will not define formally, but we will just use it as usual, okay? And if you want to learn formally, it's way beyond our class, okay? And but it's not difficult to see. You need not just assign one number to an outcome. You can assign more than one number, or two, can be 2 number, 3 number, 4 number, 5 number. Consider stock market, okay? Stock market, you can describe it by the stock market index, that single number summarizing the whole stock market. But you can also use two numbers to describe the stock market, right? Maybe big stock and small stock, right? That's a big stock index and small index, right? Or you invest in two stock, there are two stock in a portfolio, then you should have two numbers in your portfolio, right? One represent one stock. And you have 10 stock in your portfolio, you should use 10 numbers, right? Of course, you can use the overall portfolio value, but sometimes it's more convenient to model each stock separately, right? Or if you invest not just stock, you have a stock and bonds, right? Then you have two numbers. Okay. So that is not unnatural. You have more than one number because the world is so complicated, right? You have two different measurements there. Yeah, I've closed the door. Yeah, that's good. So to describe the random variable with two number, you can easily see that it's very natural to have the probability distribution function that associate two number. But that's called join because it tells us that what happened when x equal to one number, y equal to one number, right? So that would be one way to do it. Okay. And again, you have the related the big F function, right? But at that time, you have to say x less than some number and y less than some number. Okay. So same as before, these two, you can do it interchangeably. Either the P and the F are the same way to real different stuff. Okay. And just to emphasize, you may ask why we have two way. It's because for discrete, P is more natural. For continuous, F is more natural. Okay. For some mathematical reason. And because we don't go into continuous in detail, so we tell you that how we define the F in discrete case, continuous will be very similar. Okay. And one other thing that you will see from this is we have what we call the marginal. The marginal is something very complicated. Simply means that we ignore y, we just have x. Okay. How do you get that? Is basically based on law of total probability. You add all possibilities of y, then you forget about y. Okay. And this is advanced, so I don't expect you to understand what's going on. But simply speaking is it collapses the y by adding up. Okay. And you can go from P to this joint to marginal. Okay. But you can't go back. Okay. You can't go back. Because there's some loss of information from going from joint to marginal or from cumulative to marginal. Okay. You lost some information. Okay. There. Okay. So so I don't continue to go there because if I go there, we become very mathematical, which is not the goal of this class. But if you go to stat department or advanced stat class, you will learn this as well. We just assume that we know how to handle them. Okay. But this is not different, right? Just telling us you have two number. The big P will tell us what's probably I give you x equal to that value, y equal to that value. This is something we need to carry over. Okay. But we really not looking at the definition. Okay. So basically P is the thing we need to really know what's going on in terms of idea, not the main thing. Okay. So we really don't need to worry about this. Okay. And this is maybe something we should keep in your head because we use it immediately. Okay. Maybe I should blue this guy because I think this is something we were using anyway. Maybe I should blue this guy because we're using this here. Okay. The expectation, you have two random variables. If I want to add together, it's simply that because of the beauty of this formula, we get just simply sum. So that's called a linearity, right? Expectation of the sum is sum of the expectations. Okay, that's what it means. Expectation of the sum is sum of the expectation. That means that you can divide and conquer. Or the expectation of portfolio with stock and bond is just the expected value of the bond part, add up the expected value of the stock part. That's it. Okay. And if you have 10 units of bond, 5 units of stock, then you just do the same thing. Okay. So it's very natural when you calculate expectation, just everything is linear. It's proportional. Okay. And you can do divide and conquer. It's not something surprising. You think it's something intuitive and natural. And you ask why we cover this so natural thing. The reason is this is not the case for variance. It's not you can do divide and conquer. You need to be very careful about variance. Expectation, everything would follow a mind. But the risk is not linear. Say the variance of the bond and the stock is just not the sum of the variance of bond and stock. It is only true when they are independent. Okay, you can see the form. There's a caveat here. If they're independent, then the variance sum is sum of the variance. Only if independent. And you know that independent is so hard that it's almost unlikely this is true. So this formula is true in very unlikely event that X and Y are independent. Of course, that case are independent, right? You toast a coin and roll a die can be independent, right? But you toast the same coin is not independent, right? Because it really depends on how you toast it, right? Or how depend on coin is fair or not fair, right? So it's not the same, okay? So, but you may ask a question, if it is not independent, what would be the formula? Because this is the case that apply most of the time, right? So let me go to the slide that tell you that what it is, okay? It's beyond, I skipped the example first, but that is slightly beyond our class, but you learn this in your investment class. And this is the, I guess, is the most important formula in finance when you in the first 4 classes when you do investment. Why? Because you look at the formula here, the difference is this covariance. Okay? Risk of, say, bond and the stock is just sum of the risk from your bond part, risk from the stock part, but how they're related. So this covariance, okay, the formula will be similar to the covariance we learned in the first topic. Just like if they move above the mean together or not, or above the mean together. If they move in the same direction, it's positive. If covariance, they go to negative, means that one go above the mean, one below the mean. Okay? So it really relies on the idea of covariance, right? So, and that is underlying idea of investment. Why? If you learn investment, I think they talk the first few classes is what we call diversification. They tell the wisdom is don't put all your eggs in the same basket. Why? Because you put the same thing in basket, your covariance is 1. Largest covariance you can imagine. Right? Because if one egg breaks, it all breaks. If no egg breaks, nothing is break, right? So the covariance is positive, right? And if you do investment in this way, your risk is the largest, right? And the wisdom of diversification is reducing the risk, right? If one is broken, the other remains safe, right? That's why you put eggs in different basket, right? And what does that mean? It means that this covariance negative. It means that the risk of portfolio is less than the sum because negative, right? This time negative. So you reduce the risk by investing in different instruments or vehicle or investment opportunity that have negative correlation or negative covariance, right? So that's why people want to buy Bitcoin, want to buy art item, want to buy antique, want to buy NFT, want to buy stamps, collecting stamps, right? And collecting some cards, collectible cards, right? Want to buy Labubu, right? Labubu is evil, right? I mean, that's my kids told me, but I don't know how evil it is, but that's the Labubu, right? Because people call it Labubu, right? Why? Because Labubu is not changing with the price of the stock, maybe even negatively, right? So that's why that's the case, right? So maybe why Labubu is negative related to the stock market, I don't know. You can tell me, but I was told people these days, okay, don't want to show off their handbag because handbag is very expensive. So we go to Labubu, right? Because if you go to office lady, go to eat, right? I sold your handbag, you sold my handbag, right? It has not to be the same, right? You have to buy different thing, right? Because or you want to some changes. Buying a new handbag is very expensive, right? But buying a Labubu is not expensive, right? You can buy a very expensive Labubu to distinguish your handbag from others. So Labubu, the investment value is negative, right? When the economy is good, no one will want to buy Labubu, right? Probably they want to buy a more expensive handbag from LV, from other expensive brand, right? But the economy is not so good, you can buy Labubu, right? Labubu is not cheap, but Labubu is not as expensive as a new handbag, right? So buying a new Labubu, instead of buying a brand new handbag, it's okay, right? So that is the idea, negatively related. Okay. So let me go back to this example with a break. Okay. We are not going to talk about covariance, but I think this is what you learn in detail in finance, because finance, one of the big thing in the portfolio choice, and also still the big thing as well, is how to make your investment such that your covariance is minimized, right? That is a multi-trillion business, is to figure out what is a optimum portfolio mix to minimize covariance. It's a people keep doing it. They're still doing active research these days. It's still in industry still doing it. Is how to find the optimal mix to minimize this, minimize the overall thing. Okay, you have to, because in the finance class you learn there's no free lunch, right? If you want high return, have to accept high risk, right? But the risk is what we call undiversifiable risk, right? So you have to figure out that this is not the risk part, right? If you do something stupid, right? This part can be reduced by your good calculation. Okay. So because this is diversification, right? The only thing you take risk and return trade-off is the undiversified risk. If you diversifiable, right? It's not something rewarded by the market, right? So you have to learn how to diversify the risk. Okay. Okay. So let's go for this example. Although we don't talk about covariance because it's a complicated subject that you will learn in investment, but still, I want to show even though they're independent, there's still portfolio choice problem. There's still a risk and return trade-off in this idea here. Okay, but not explicit, but still the risk and return trade-off from the taste of investor. So you can see there's two stock here. X have where return 10%. The variance is 0.05. Okay. And stock Y have the return 5%. Variance is measured by 0.01. So you can easily see without a problem, one offer high return, but higher risk, right? Larger variance. Y has lower return, but lower risk. Okay. So consider a portfolio that is equally divided between two stocks. Z is 0.5 of X and 0.5 Y. Okay. And of course, Y half and half. There's a choice. You can tell me what is your take. You need not be half and half. It can be 30%, 70%, or 20%, 80%. It's your split. You have to tell me which one is better for you. Okay. But we do the calculation half and half. You can do any calculation that fit your taste. Okay. That is the thing you tell your client if you're a financial planner or you decide yourself. So let's calculate if you do half and half. Okay. You do different one and figure out the best for yourself. And if you have half and half, portfolio Z is half of X and half of Y. Okay. And because expectation is simple, we just separate the two, right? Because we said we can always divide and conquer without any problem for the mean, right? We separate them. Expectation or sum is sum of the expectation. That's the case we said. And expectation is also good is you have a number, you can take it out without any problem. So take it out. Okay. And expected X is 0.1, so we just put it here. Okay. And this 0.5 here, expectation of Y is 5%, so put it here. So your portfolio, if half X, half Y, is 7.5% return on expectation. So expect this is a return, you get 7.5%. Okay. Now, of course, we not only care about the return, we care about the risk. If the risk is measured by variance, and we assume, as I said, this is not the good assumption, but assume X and Y are independent, okay? Which may be okay if, say, the stock is X is US stock market, Y may be China stock market, right? Likely they're independent. Or X is stock in US market, Y is market in India, say, for example. They are more or less, okay to say independent, okay? And the variance of Z is equal to variance of 0.5 this portfolio, okay? And because independent, you can write this. Variance sum is sum of the variances. But do note that if they're not independent, you have to add back the covariance, okay? And it go up and down, depend they're positive correlated, negative correlated, okay? But we are independent, so our life is easy. But do remind you, if you the investment class, you must add the covariance because independence is very strong. It's not almost never holds unless you're not talking about investment, right? In that case, the next step is very carefully. 0.5 is not, you can just not take it out. You take it out, you have to square. So remember, the variance have the square term, have to square, okay? And you do the calculation, it is only 0.015, okay? And do notice that this is not the halfway between the variance X and Y, right? If you look at it carefully, right? So it's not that much. But this is, you can see this is how this thing, okay? If you tell me half and half, this is my return and this is my variance. Then you can look at different combination. You can plot different possible return and risk. Then you pick the one that fit best of you. That is how you allocate your portfolio, right? You have different combination, you have different risk and return choices, and which fit your taste, of course, is a matter of your risk preference. I can't say which one is better because it's independent, so there's no simple best way, okay? But you at least will see there's some way to allocate your portfolio, right? At least this is a investment class 101, right? Is that okay? But of course, I said if you want to be serious, you should then assume independent. You just have a covariance term there, okay? And you learn from the investment class how to calculate in those situations. Is that okay? So I hope at least before the break, we tell you how to apply what we learn in the investment class, right? Okay, because that is investment class required course for everyone, right, in the base school. So I hope that will be helpful. After the break, we'll talk about some common distribution in discrete random variable. Okay, why are we doing that? Because so far the P and the F are not really structured, right? P and F just tell you that I give the number, you give me for probability, okay? And we didn't go further, okay? And here we tell you that we study 5 common scene discrete distribution, 5 common P function, okay? And for example, the Poisson is very similar to the bell curve. Later you will see. And binomial close to the bell curve. And Poisson hypergeometric will be something that you will see very often. Some applications, say Poisson will be very useful to model how many people would come in the next hour, right? How many customer will arrive, okay? Those kind of arrival problem. And hypergeometric will be very good looking at a auditing problem or quality control. Say out of 10 objects, you have 5 is broken. If you draw 2 objects, how much you have been broken, how much is good. So it's very good for auditing. And of course, if you look at the web, there are at least more than several dozens of common discrete distribution. In our class, because time constraint, you can focus on 5. But in the application, you can find a lot. Okay. And of course, that is a lot from physics and engineering. Okay. And that's will be very useful when we talk about mathematical modeling. Okay. We don't go to a lot of detail, but if you try to model the world, I mean, that this kind of thing will simplify our idea on the P, right? Because P can be very complicated. Okay. And we have a mathematical approximation to fit in something much more simpler. So basically, we're trying to reduce the complexity of P. Okay. So we'll do it after a break. Let's have 15 minutes break. As usual, we will do a you reply. So please help me to do it as part of your participation and attendance. Okay. I'll see you in 15 minutes time. So we will resume at 10:38. So how are you? I hope everything was all right. Let's see. Sleepy. Uh, I'll upload the record lecture. I think this Wednesday, right? Last Wednesday is there, but I upload the video when I get back to that. Um, the next one, which coffee recommend? I don't know. Any coffee is good. In particular, actually, I like the coffee in the CYT. There's a coffee shop in the third floor of the stage. The uh, the black coffee is pretty good. I mean, I would say when you get older, you like black coffee. You appreciate black coffee way more than other milk coffee. But before you do that, um, it's okay. Well, I think it's a very classical statement on the TV show is uh, real men drink black coffee 叫真男人就飲黑咖啡齋啡 It's an old statement in TVB show. You can check it out. I don't understand, but I do understand when you try to appreciate the why, because if you can't feel the black coffee, you are super tired. So because your tongue can't distinguish, only by the black coffee you know your existence. So that means any coffee is good. Um yeah, I think, but today I drink tea. The Japanese tea without milk is Korean milk tea. I think it's also okay. You love my dress, but I have pants, no dress, unfortunately. Uh, I like dress, but not on myself. Okay. Uh, today's Friday. Hungry. Yes, that's good. Oh, this time all of you in correct because today's Friday. That's nice. The weather. Okay. So you can see even this question, we don't have unanimous. We're surprising, right? Because every time we're aware that we have unanimous on this one. So you can see even from this, it's not easy to get the same answer. Key point. Yeah, that's very important. The variance of x plus y equal to the sum of the variance is only x and y independent. Stat. Join PDF. Adding covariance when x1, yes, that is true. Yes, that is important when you do investment. Sum of expectation, sum of variance. Yes. So get back to here. Most of you think the speed is okay. Easily can follow. Any jokes? No jokes today. Snippy and need coffee. Yes, you do. I think we do need coffee. I mean, you are thinking that you are very tired, you work a lot. Think about when you go to work, how many hours you spend on working, right? So, as I told actually my teacher when I was in the school 20 years ago, they said, at least you should study 8 hours because you are a full-time student, right? So make sure that at least you satisfy that constraint, right? Otherwise, you will be surprised when you go to work, right? At least 8 hours of study. Actually, I tell this to my kid as well, right? At least 8 hours, right? Sometimes my mother isn't home. I sit in the bathtub, cover myself in baked beans, and pretend I'm bean among beans. Okay, that's good. I don't know. At least I don't have bathtub at home, but headache. No, sorry. I'm a joke. Okay, I think that's what my kid often said to me. I'm a joker. How's your day? Hungry. So many people are hungry, but why? It's only not even 11. Why you are that hungry? Must be you don't have breakfast. Otherwise, your stomach is so efficient. Okay. So I hope that your group break. So now we have understand P and F are the way to describe random variable, and we want to tell you some application, right, of how to make random variable useful. It's because of we study a certain structure we impose on the P, and this kind of structure is very useful when you try to model a lot of business scenario. Okay, it will become more clear when I go to the application. So hopefully I cover the first three, then leave the last two in the next class. So the very first one is called uniform distribution. What's that? It is simply very simple. For every value in your support of the random variable, each one is equally likely. Okay. And for example, you have n outcome, and each outcome will be 1 over n. And do note that x1, x2, x3 is just some number, right? x1, x2, say x1 is typhoon signal number 0, 1 is 1, and so on and so forth, right? And they need not mean anything, right? And the simpler one is 1 over n, right? And if it toss a fair coin, it's like this. If you roll a fair die, it's also like this, right? And if you play board game, you know that die need not be 6 faces. It can be 10, it can be 20, right? So that is also the same thing apply. And you ask, why in the world we care about this? Is so easy, right? Why we care about uniform? One thing that is why uniform is good is because if you don't know, if no idea about what to assign to the P, the first step to do is use this uniform. You don't know which one, so each one is equal likely. So P would be our Pyra. Okay, it's our initial what we think. And we learn from experiment, we learn from data, use Bayesian updating rule, Bayes rule. We can go from this uniform to much more complicated P. And that is how learning being done. Usually we start from uniform if you don't know what's going on, right? And then based on our new evidence or new knowledge how the system works, we go to more complicated idea. So that's why we learn Bayes rule, right? But of course, we didn't tell you how exactly operationalize that. But that is our future classes will be doing, right? If you are a quantitative finance student, if you are actuarial science student, or if you are other student that we do, then this is how you study, right? For example, in marketing application, maybe you don't know your customer base is going to be more men or more women, more adult or more kid, more old man, so on and so forth. There are many categories of customer, right? Then each one will be uniform, 1 over n, right? Different groups. And of course, over the time, based on your data, people consume data, then you can update it. It no longer be 1 over n, but you will start from the very basic. Okay. Okay. If you are look at the graph of P, right? Because P is sufficient to describe the random variable, right? If you have 1 up to 5, then it's a flat 1. If 1 to 3 is higher, but it's equally divided among. Okay. So this is we start from something very trivial. Okay. Hope understand what we are doing. Now we're going to something less trivial. Now go to something realistic. Okay. As a lot application. It's what we call the binomial distribution. Okay. You can see Benoni is a guy, actually binomial family, but a three person in this mathematical family. They invent a lot of things in math and statistics. I think that the first few guy who did the thing, and he just considered the world has two outcome, success or failure. Okay, imagine in the world that you have many possible outcome, but you have a binary view in the world. It's either outcome is success or failure. What you do that? if at the end of semester, you don't know what to do, you don't think you're doing good grade, what you do? Ask for this class, make it pass or fail, right? That is, you can do that, right? I think at least for some class, I don't know whether are available for this one, but at least in the first year, you can ask for pass and fail. And I don't know whether they allow here, but at least in Singapore, allow that to happen. For some classes, you can allow pass or fail, right? That means that no longer give you A minus, B plus, B, right? And C and D and F, right? You just collapse the world into two, either success or fail, okay? Of course, you can allow more than one outcome, but will make our life easier is binomial, You can allow more than one outcome, okay? And these two outcome not the same probability. If the same, that's uniform, right? So we allow probability P is success, 1 minus P is fail, okay? So this is the world, it's binary world. And our random variable is counting number of success, right? Good outcome or bad outcome. Good is success, bad is fail. So it's either 0 or 1 because you only have this once. Okay, we'll do allow more outcome to realize in the next one. Okay, but now if start from the very beginning, we only have one possible success or no, 0 or 1. The next one binomial we allow more than 1. Okay, we only allow because you just only do things once, success or fail. That means that it's 1 or 0. So your support is 0 or 1. Okay. And you can write it P of x1 equal P, x equal 0 is 1 minus P, right? That means that the P function, which is the most important thing, when we describe the random variable, is we give us what are the number it can be and what's the probability, right? Because this is complete description of the world. So it's 1 minus P and P, right? Because 1 is P, fail is 1 minus P, okay? And you can imagine posing a coin, running an experiment with binary outcome, or the world is so simple, we no longer care about A, B, C, D, E, F, G, H, D, right? We only care about pass or fail, okay? Say if you do accounting, simply this is, you don't care about how much money or how much loss, you just care about the company is making profit or making losses, or the company has no going concern, going to continue, or it could go bankrupt. Okay, so it's just binary. Okay, or at the end of the day, you write an auditing report. You say the statement has no problem, or statement has problem, right? I have no reservation, right? Something like that. Okay. So now we go to something serious business, right? We go to something like crazy math here. Okay. Remember, we have is P of 1 is P and P of 2, sorry, no 2. P of 0 is 1 minus P. Okay. Now we have a mathematical trick, okay, that will blow your mind because math people like to write something very compact. Is you can write this into this guy. Okay. You may wonder what we're doing. It will be clear in the next few slides. But what it is doing is if you put x is 1, you have P1, 1 minus P, 1 minus 1. That means that it's P1, 1 minus P0. Why this is good? Because P to the power 1 is just P, right? This is simply P. And this is simply 1. So go back to here. Right? So P of 1 is this guy. And P of 0 is simply P raised to the power 0, 1 minus P, 1 minus 0. So it's P to the 0, 1 minus P1. But this is simply 1, this is simply 1 minus P. Okay, so go back to here. Okay, so we can now for one day become mathematician. we write this complex thing into this form. Okay, you will see why we do this. Okay, we are not doing this for crazy thing, just being a mathematician. Okay, but you will see clearly very soon why I write this. Okay, but just bear in mind, bear with me. For 5 minutes later, we will explain. Okay, why we write this form. There's some benefit for doing it. Okay, just bear with me. Okay, so you can calculate the mean of x is p, y is very simple, right? Because this is x have two values, 0 and 1. P is p and 1 minus p, right? So the mean of x will be 0 times 1 minus p and 1 times p, which is just p, right? Because we take the 0 times the probability. This is 0. 1 times p, which is p. 0 plus p, p. This guy, I mean, already in your slide, in the next slide. So I just write down here. It's about 2 slides after. But I just write down because I don't want to move around. Okay? And you can also prove that the variance is p1 minus p. You can calculate that. Okay? It's in the slide, so I don't want to show it. But rather, I want to show you the picture. Okay? Now, for those who learn M1, they're very happy because many of them is here. But I will show the benefit of M2. So variance of x is p1 minus p. Okay? If you are M2, you should be able to do it quickly. What is, if this is p, this is p1 minus p. What's the graph looks like? It will be, looks like this. P is from 0 to 1, right? It will be look like this. This is 0, this is 1, this is 1/2, this is 1. This is contrasted equation as the maximum achieved at 1/2, right? At peak at 1, right? This is, you learn in M2, but M1 also learn it, right? Actually, basic math also learn it because this is a contrasted equation, right? Because this is just, if you learn it, this is negative p squared minus plus p, right? Like this. Okay? Is that okay? Because you put 0, it's 0. You put 1, it's 1, right? So why I want to draw this? Okay? Remember what's variance? Variance is how the data will look like and how it deviates from the mean, right? The mean is p. Okay, remember the mean is p. So let me show it. Why if, so let's look at the special case. What happens if p is 1? It means that your experiments always success. You always have success. It means that you always have 1. So look at the data. You always 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. The mean is 1. The variance is 0. Why? Because everything is 1. Right? Now look at the other case. What happens if p is 0? Every time is failure. Okay? Your data will be 0, 0, 0, 0, 0, 0, 0, 0. That's why the mean is 0. Right? Expected x is p. Right? Your mean is 0. And it's all 0. Then you ask, why is highest at 1/2? Because your data will be half of 0, half of 1, and the mean is 1/2, right? The distance is the maximum, right? Is half of them is 0, half of them 1, you're in the middle. The distance for everyone is a maximum. It's 1/2 square, 1/2 square, 1/2 square. Right? Just remind you what's 1/2. 1/2 means that your data is like this, right? You have 0 and 1. You have many data here, 1 or 0, many data, right? And your mean is in the middle, 1/2. So the distance is, you take this square, right? You take all the distance, you square it, add up together. And this is the largest, right? Because it's either 0 and 1, the middle is 1/2. If other p's, then it will be less likely. Because say, suppose p is less than 1/2, okay? Then you have more failure than success, right? and your data have been more closer to zero, right? The mean is also there, then your variance actually reduce. Okay, so that is why the case. Okay, so that's how this looks like. Okay, is that clear? So I hope you understand, right? The variance lowest when there's most success or most failure, right? Because you know you're going to success, P is say very close to 1, you're going to success a lot of time, then you are very likely to success in the data and very few failure, right? So there's not much variation, right? A lot of success, very few failure. Or P is less than 1/2, right? Close to 0, then you have a lot of fails, not much success. You don't have much variance as well. Okay? So that is the thing. Now, look like this, okay? If P is half, so equally likely success or failure is the red bar, but it's possible that P is less than half. It will be P of 0 is more than P of 1. If P is 0.8, then it's more success than failure. So this is the simple graph there. And the proof, I have done it. I think you can try yourself at home if you want to do math, but if you don't, you can forget about it. As I said, you only need to know the purple color box. Okay, the black box is for people who like black box, right? Or sorry, to like to open the black box. Okay, instead of that's why I do the black box, right? I put it in the black box so you don't have to understand. But if you want, you do it. So now we try to understand why we become mathematician in the past previous two slides, right? Because want to introduce you, one of the most useful thing in discrete random variable is what we call binomial distribution. What is that? And later you will see this is very useful also in actually related to option pricing. Okay, it's called the binomial tree. Is actually related to this one. Okay, so here is binomial. Sorry, binomial is actually consists of n independent binomial trial. Remember, binomial trial is you have P success, probability P success, probability 1 minus P got fail. It's very simple, right? It's a binary outcome. P success, 1 minus P fail. Okay. Now consider the case if you repeat this n time. Okay. Then you care about how many times you success. You don't care about order. You just care about the total number of success. Okay. Add up together. Okay. And this would be what we care. Okay. Later, you see example how we apply it to practice, but the definition is very simple. We have n different or n independent binomial trial. Each trial is same, is success or failure. Means you open many boxes and different boxes. Each box is success or failure. Okay. And this is actually related to the assignment question or the last example we get in the last topic, pros and cons, head or tail, right? And here is we want to know how many of success is either 0 up to n, right? And turn out to be this probability exactly x success come from p raised to power x, 1 minus p, n minus x, and ncx. I'll explain this, but this is the formula. Explain why we need to talk about combination in the last two classes, and why we need to see this particular thing before n is 1, right? X, p to the x, 1 minus p, 1 minus x, okay? I'll explain this formula very soon, but this is what we have, okay? To see this, let's draw a tree diagram, okay? I think this is easier to think. So in your first trial, you can have success or fail Success have probability P, fail 1 minus P, right? And of course, success means this is 1, right? Fail means it's 0. Now we do another round. Because independent, your success or fail and success or fail with same probability, P 1 minus P, P 1 minus P, right? That means that this is now the random variable. Because this success, this become 2. Because 2 success. Only 1 success here, only 1 success here, 0 success here. Is that clear? What is it doing? Okay. And you will see P of 2 is P squared. Why? You just, 2 is only 1 branch. You use the multiplication rule, you multiply another branch, P times P, right? And what's P of 1? P of 1 is these 2 cases. So it will be this plus this. So it's P 1 minus P plus 1 minus P, P. So it's 2 P 1 minus P. And same P0 is here. That is 1 minus P squared. Okay. So now you can see why this is related to combinatorics. Why? To get x equal to 2, you have 2 success. There's only one way to have 2 success, is you have both success, right? That means that it's actually the same thing of tossing a coin, head or tail, right? If you need 2 success, you have to draw ball number 1 and ball number 2, right? Now we consider the case is you have 2 balls, okay? If you draw this ball, this success in that round, okay? You have 2 rounds, so you have 2 balls, number 1, number 2. 2 success means that you draw both balls. That is actually 2C2, right? And how likely it is P squared. So this is exactly, is saying that it's 2C2 P2 squared, 1 minus P, 2 minus 2. Right? And similarly, why you get this guy? This guy means that I have ball number 1, number 2. I have failed, both fails means I don't draw any balls. Right? Because how many damage I don't draw any balls? That means we have 2C O P to the power 0, 1 minus P, 2 minus O. Right? Because I actually choose 1 minus P 2 times. Right? Because for each fail. Okay. And similarly, this guy is 2C1. Why 2C1? Because I have 2 balls, one named number 1 and 2. I can draw ball number 1 only, or I can draw ball number 2. Right? And in that case, it's basically I choose when to have success, right? First round or second round. That's why 2C1. Why 2C1? Again, I repeat. You have 2 rounds. It's same as you have 2 balls. That's ball number 1, number 2. Okay. I only allow 1 success, so it means that I only draw 1 ball. That's why 2C1. And for this 2C1 is 1 success, means that I have P to the power 1, 1 minus P to the power 1. Why you multiply? Because they're independent, right? Remember the independent rule, right? If they're independent, you just multiply, right? Along the branches. So that's why the formula will be NCX, P to the power X, 1 minus P, and minus X. You can generalize this, okay? Again, this is a black box. If you get it, you get it. You don't get it, you memorize it. That's how I learned the first round. I don't understand. To be honest, I don't understand the first round. So I just memorize this formula. I bring the cheat sheet to the exam. And after several years, I understand. Okay? I don't immediately, but it's okay you don't understand. But if you don't, it's not the end of the world, right? But if you do, it'll be good. I hope you understand why we have that. But if you don't, that's fine. It's not something that you have to understand. That's why it's in the black box. So that's why what we do is, okay, is I give you the formula using combinatorics. We know this is going to be true, okay? If you don't like it, forget about it. This is what it is. Trust me, okay? Source is brother, me, okay? Trust me, okay? That's the result. If you don't want to understand, this is the case, okay? I explained already here. This is what I have said, okay? Now, and not surprisingly, this is given to you, and mean of x is NP, right? So suppose P is half, okay? Half of time you get success. If you repeat 10 times, you expect 5 success, right? And that is why this, right? But because of, again, is expectation of sum, is sum of expectation, right? So it's n per child, each one is P, n times n of those, so it's NP, okay? And the variance, the same idea, because they're independent, variance of sum is sum of the variance. Each variance of one trial is P times 1 minus P. And together, that's why NP 1 minus P. So that is the idea. Okay, again, I'm not expecting you to know the logic, but at least you have to know the formula because that will ask. Okay, of course, you bring your cheat sheet anyway, not asking you to memorize it, but you know where to find your answer. When you do the assignment, you know. Okay, so this is the shape looks like. As I said, if n is large and p is close to half, it's like a bell shape. Okay, and later you learn when n is very large, you will very close to where to go to bell shape. And indeed, when n is super large, this is similar to normal distribution. Okay, but let me at the end give you an application. Okay, because we talk about this again, is about a restaurant. Okay, figure out that from the data, 30% of a customer like spicy food. Okay, that means that he want to know how likely that if upcoming 5 customer, 2 of them like spicy food. Why this is important? Because he need to think how many spice he have to prepare, right? If like spicy food, I have to buy curry, right? So calculating this probability is very important to understand what's going on, right? So this is very applicable in the real world phenomenon, right? You look at data, tell us how likely that things happen. You look at, you have 5 tables, then you look at how many spices to prepare. So we have to calculate exactly 2. Of course, you can calculate exactly 1, exactly 0, exactly any number you can calculate, right? Because we know the p distribution. And just need to apply the formula, right? Because it said you have 5 customer, means that you have 5 people. Okay. Okay. And each one will have 30%. Okay. Say they like spicy food, right? Then you want to see exactly 3 of them like spicy food. So that means that you have n equal to 5 because there are 5 people to ask. And each one okay have 30%. Okay. They like spicy food, right? So that's right. And 30% does not. 70% not, right? When there's some spicy food, then they will right? So you want to do that, right? P is 0.3 and 1 minus P is 0.7, right? So the question is asking you probability that X equal to 2, or what we call P is 2, right? P of 2. And the formula is like this, right? Is NCX PX 1 minus P N minus X, and the small x is 2 here, right? And P is 0.3, N is 5. Put that in, is the answer. Of course, you need to calculate that, but Excel actually will give you the answer immediately, but you can do your calculator. And turn out that 30% of time, you have 2% would like spicy food, right? And they can calculate probability that how many percent you're 3 or 4 or 5, right? Because you can calculate every number, right? Putting different number on small x. Then you have some idea that how many spice you have to order, right? That's very common question, right? Is application in restaurant operation, right? If you are doing hotel management, this is what you need to prepare, right? Is that clear? We'll talk about more application, but you will see this already very applicable, the binomial. Okay? So I'll see you next week. Enjoy the weekend.